Welcome to HP Tuner's GM Gen 5 training part 13. In this training module, we're going to be learning how we can work with and tune our low side pressure pump. We're going to have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our low side pump control in our GM Gen 5 applications. This tutorial is going to go over understanding the low side pump, the fuel pump control module, how we can go in and start to change some things within the low pressure pump control routine so that we're able to feed our high pressure pumps, which is the direct injection pump, enough fuel flow rate so that we're not going to have a drop off on the high pressure side. So the low pressure is going to be equally as important as the high pressure, and a lot of people overlook the low pressure pump. A lot of times when we're having high pressure pump control issues, so we're dropping pressure, it's oftentimes because the low side pump isn't keeping up and able to supply enough fuel flow rate. So the high side pump that's mounted on the engine, that's actuated based on our engine's movement, that's going to be essentially a multiplier. So we feed our high pressure pump with our low side pump. The low side pump pumps the fuel out of the tank. It's going to run at a desired pressure, which we can program here. We're going to take a look at that. And that feeds enough fuel flow rate to that high pressure pump. The high pressure pump multiplies it, and then it goes from, let's say, 400 kPa, 58 psi of pressure on the low side, and it can go outwards from that pump 2,000, 3,000 psi. So we can have a huge multiplying effect with that direct injection mechanical pump fitted to the engine. Only is going to work properly if the low side pump is set up and it's feeding enough fuel. Now, if you have a stock fuel system and you're trying to make a bunch of power, you're going to run into limitations not only from the low side pump not being able to keep up to the high side pump, but the high side pump not being able to run enough pressure and not deliver the sufficient fuel flow rate you need for that higher power level. So there will be limitations where we're going to find we have to change out hard components, and we have to change out the low side pump to something, let's say an upgraded single low side pump or a dual pump set up for the low side so that we're feeding the high pressure pump with enough fuel flow rate to go in and deliver that higher rail pressure that we're requesting through some of our other programming tables. So this is just going to be focusing on the low side pressure pump and tuning. Next tutorial, we're going to talk about the high pressure pump and some things we need to know about dialing that in if we've changed out our cam with an overdrive lobe, or if we've changed out the pump itself, if we're an LT1 and we put on an LT4 pump. What do we do? What do we change? We're going to deal with that in the next tutorial. This is going to take a look specifically at the tables for programming within the low side pump control, the low pressure pump control, taking a look at some log data and just understanding what we need to look for and in just general how this is going to work and what changes we need to make if we're upgrading the pump assemblies. There are going to be some specific tables and specific sections that we need to make sure we're updating so that we don't get overshooting and undershooting in the pressure control if we're on our low side pump, and making sure that everything is going to be in check and we're going to be delivering the fuel flow correctly to our high side pump. So the first thing that I want to do here is just talk about the fuel pump control module. And let's talk about how that relates to our low side pressure control. It's actually a relatively straightforward system. There are some more advanced kind of number crunching going on in the background in terms of that control, how the control routine works. But just on the front end of it, on the basic side, understanding the components and what goes on here, let's talk about that. We don't need to dig into all the nuts and bolts of how it actually works in terms of crunching the numbers. Let's just understand mechanically what's going on here. So we have a fuel pump control module that's controlling the low side pump. We have a fuel pressure sensor that's fitted on the outlet of the low side pump, which is feeding the high side pump. That fuel pressure sensor is going to be monitoring what that low side pump is putting out. It's going to report that fuel pressure back to the fuel pump control module. Now, we're going to be supplying, the engine control module here is going to be supplied a target pressure that we want to run at that provides the fuel pump control module on the CAN bus network what that desired pressure is going to be. It takes a look at the pressure from the fuel pressure sensor on that low side line, and it sees how far off from the target it's going to be. So if we're requesting 400 kPa of fuel pressure and we're at, let's say, 450, it needs to manipulate the voltage and amperage to that low side pump, so the low side pump will put out what that target pressure we're requesting is going to be. So if we're asking for 400 kPa, we should be at right at 400 kPa.
If we're asking for 500 kPa, we should be at 500. If we're asking for 300 kPa, we should be at 300. So we'll find that it's a dynamic system. We will be switching between different modes. So there's going to be a low flow, a normal, and a high flow. There's also going to be a couple other modes mixed in there. We're going to find that the fuel pressure will vary based on the mode that's requested. We'll talk about how those modes are calculated here in just a little bit. But what we're going to find is that the fuel pump control module works in a 0 to 100% duty cycle scale. It is a solid state relay. Solid state relays are able to switch very quickly in a duty cycle type of format. So 0% duty cycle will have no voltage and amperage going to the pump. The pump won't be running. 100% duty cycle will feed the most amperage, the most voltage to the pump, and the pump will perform at its highest level and highest fuel flow. We're able to manipulate that duty cycle at any given runtime of the engine's operation to reach that desired target pressure.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.